Hi, hopefully your quiz was easy peasy. If not, get those formulas down before the test on Thursday. Today we're going to talk about pyramids and cones, so that's your other 3D shapes. And just like prisms and cylinders, they have a lot of things in common with each other. First off, some characteristics that you should know um, of your pyramid are that all the faces except for the base intersect at one point called the vertex up here. We talked about that on Friday. The base is always a polygon, so it can be a square, triangle, pentagon, anything like that. It's always a polygon. All the other faces are triangles. So the lateral faces are triangles, and then they still meet at lateral edges, still same definition. The altitude or the height is the segment from the vertex to the center of the polygon. So that's the same definition. The new one, because we have these triangles and they slant up to that point of the vertex, we have what's called a slant height. And that comes into play when we talk about our surface area, because remember, surface area is how much material it would take to cover something. So we have to take into account kind of that height instead of the height of the actual pyramid. So height of the pyramid is from the vertex to the center, but the slant height is actually this height of that triangle, or the height of the side. So then your total area or surface area is represented by the formula 1/2 PL plus B. So the 1/2 PL is the perimeter of the base, just like always. The L represents the slant height. We will still use an H for height of the pyramid, but it's not needed for this formula. And B is still area of the base, but the reason why we only have one B is because there's only one base. There's not parallel bases in this one. So as you probably can assume, Pythagorean theorem will be used a lot here, because you could be given the height, you could be given the slant height, you could be given a side. Just depends on what type of problem you're given as to what you need. And Pythagorean theorem is a nice tool to have in your back pocket. All right, so real quick, we're not doing lateral area. That is not a concept that you need to know, so mark that out. But we are going to find the surface area of both of these triangles, or pyramids, excuse me. So first off, this 18 represents from here to here. It's not marked on your paper, I don't believe, but that is what the 18 represents. This 18 is the same as over here. So 18 and 24 are parts of a right triangle, which would tell me the slant height is 30. If that side is 18, then the whole side is 36, making the perimeter of that square 144, and its area 1296. So when I plug in my formula 1/2 P slant height plus B, I get 3456. On this picture, you are not given this number over here. You're given that piece right there, an 8, a 6, and a 4, which is everything you need from your triangle if you were to solve it. But what you need to remember is that this is the center. So if this is 4, the whole side is 8. So that makes the perimeter of the base 32, because 8, 8, 8, and 8. The slant height is 8, that is given for you. And then the area of the base is 64 from 8 times 8. Then 1/2 PL plus B will tell us our surface area. So 0.5 of 32, 8, and 64 gives us 192. So 192 here is our surface area. Next is the volume of a pyramid. Pyramid, the wonderful things about volume is the formula is always the same. It's the area of the base times the height. The only difference is, because this is a pyramid and the sides are slanted, it's actually 1/3 of a prism. If you took a cube and cut it up into pyramids, you could actually get 3 pyramids out of it. It's really cool how it works out. So if you have the same base, the cube and the square from the cube, and a square and a triangular pyramid, it would take 3 pyramids to make that one cube. So it's 1/3 area of the base times the height. B being area of the base, H being the height. So you see where the slant height, hopefully, is important for the surface area, whereas the height of the actual pyramid is important for the volume. Because remember, volume, we're filling it up. So that is very important to know how far the center is from the vertex, whereas the slant height tells us how much paper to wrap around the side. So then we have these two problems here. In the first one, you're given the height, which is nice. The area of the base would be 9, because 3 times 3 is 9, times 7, and then you multiply it by a third. If you notice, I forgot the third in the very beginning of doing this key, so it's very easy to do, so be careful. In this case, 21 is our final answer. In this one, we're given 8 as a side, so 64 is the area of the base, times 6.5, and a third of that is 138.6. Repeating. You can write as 1.67, 1.7, whatever is fine. If you have any questions on pyramids, now's the time to ask Miss Lewis. Next, we're going to talk about cones. The neat thing about a cone is it is very similar to a, you guessed it, cylinder. Here is what a cone looks like and all of its wonderful little characteristics. The great thing is the base is always a circle. So again, in our formulas, we're going to be referring to circumference and area with circles. The vertex is point V. The axis is the same as its height. And it has a slant height as well because it points into that B. So we have a radius, we have a height, and we have a slant height, which is S, or we can scribble that out. That's still our little cursive L. Surface area is very similar to that of a pyramid. 1/2 PL plus B. Well, 1/2, remember perimeter of a circle is circumference, so that'd be 2 pi r. L for our slant height, plus the area of the base, which is a circle. 1/2 times 2 is 1, which is where our formula comes from. So pi RL plus pi r squared is our formula. So these cancel, which is where it comes from. So then apply that to all our little party hats down here that we have. And it's very easy to do. You just plug it in. On the first one, you were told the whole diameter is 5. So my radius is 2.5. You're given a height of 9. They need to be careful because remember, height is not used in these surface areas because height is from the center to the vertex. We don't need that. We need the slant height to see how much paper would cover that party hat. So we use our Pythagorean theorem to find that the height, the slant height is actually 8.65. So in our triangle, what we would solve is 2.5 and 9 being our hypotenuse. 2.5 is because our center is right here over. And then use our a squared b squared equals c squared to find it. Then plug it in our formula, gives us 21.625 pi. Or if you type everything in your calculator at one time, about 67.94. The middle problem is the exact same type concept as the first one, and so is the last one. You're given the slant heights on these, which is kind of nice. So you just plug it straight in the formula. So 6.44 pi and 20.24 pi. So pay attention to the difference between a slant height, which is labeled on the outside, or the actual height of a cone. If you're given the height and you need the slant height, use the Pythagorean theorem. If you're given the slant height, plug it straight in the formula. Just like a pyramid, the cone is 1/3, so a cone is actually a third of a cylinder. So if you had the same bases with the same radius and same height, it would take 3 cones to fill up a cylinder. Kind of cool how that works out too. So our formula in this case, because the base is a circle, is 1/3 pi r squared h. So here are our examples that you are given on your paper. We'll work through those. The first one, you're given the radius and the height, so it's everything you need. You plug it straight in, you get 100 pi. The one below it, again, everything you need. Plug it straight in, you get 320 pi, or the decimal answer is appropriate. The last two, they're oblique, but the great thing is you're still given the height. That's what this little dotted line on the outside means. So it's okay, we just plug it straight in. And remember, in this case, if I was given the slant height here, you have to have the height. So use the Pythagorean theorem to find it. If you have any questions on cones, Now is the time to ask Miss Lewis. If you have any questions on anything with pyramids and cones, now is the time to ask Miss Lewis. If you don't have any questions, the worksheet you got yesterday where you went up to problem number 10, you need to complete it tonight with practices on pyramids and cones. Tomorrow is about spheres and hemispheres, reviewing for your test, and the test is on Thursday. Remember that first part of the test will be matching all your formulas that you need to know, and then applying them will be the rest of the test.